So in this video, we are going over a similar problem to homework to problem 7, just to prepare you guys for said problem in the homework. So in this problem, we are told a couple of paths that a mail carrier takes, and we are asked to draw their motion, find their net displacement vector, figure out how far the restaurant is from the post office, figure out their displacement vector on the return trip, and figure out what their compass heading is on the return trip. And you assume the positive x-axis is to the east. So we're just working with vectors, doing some addition and subtraction. And we're introducing the idea of displacement. So we know he drives 20 kilometers north. 20. Then he travels 30 west. 50 kilometers northeast. And then 40 kilometers north. So make a drawing of their motion. Well, here we have a drawing which represents the path that they are taking. Now it says find their net displacement vector. Well, their displacement vector can be represented as each individual vector, right? There's 4 vectors total. We can write them in their component form, x, y. And if you wanted to, you could use IJK notation. I prefer the just x and y in the vector form. So for the 20, first vector, wants a 0 in the x-axis and a positive 20 in the y. It's just straight up by 20. And of course, we're going to assume positive x is to the right and positive y is up. That's important to establish. Vector 2 is 30 to the left. So that's negative 30 on the x and 0 on the y. Now our third vector lies at an angle. He travels northeast. When he's traveling northeast, we know it's directly northeast, right? 45 degrees to the horizontal. So if we take that vector 50 and bring it out here, and sort of establish what it looks like. Now, how do we find the x and y component? Well, we can use trig. If we convert this into a triangle, we know that this is 50, hypotenuse is 50, this is our y component, and this is our x component. We have a 45-degree angle. And so by using SOHCAHTOA, where sine of theta, so sine of 45, opposite over hypotenuse, right? Opposite is y over 50. And we can use cosine of 45 equals adjacent over hypotenuse. And of course, solving for x and y just means multiplying both sides by 50. So when we write this vector, well, we know it's in the positive x and positive y direction. And our y term and our x term are given in here. It's a little cryptic. We're going to just sort of skip a step of writing it out, where x is 50 cosine 45. And our y is 50 sine 45. And so that's the most complicated vector. When we go back to the fourth one, we notice it's just 40 in the positive y direction and nothing in the x direction. So we have found all of these vectors, but how does that get us to our net displacement vector, right? If you remember a displacement vector, it is sort of the vector from the start to the finish, right? And so you can represent their net displacement by adding all of these vectors together. So we first add all of the x components. We have negative 30, and we have a positive 50 cosine 45. And then we go into the y-axis, where we have a positive 20 plus 40, 60, plus we have a positive 50 sine 45. We're just adding up every single y component. We're ignoring the zeros. So we have this vector, and we plug it into a calculator to get 5.35, comma 95.35. So that is their net displacement vector. Now, we're on part C. How far is the restaurant from the post office? Well, that means the magnitude of the distance. And we're talking just a straight line, right? So magnitude, if you remember, the magnitude of a vector v, put that arrow to represent a vector, is the square root of vx squared plus vy squared. And so if we want to take the magnitude of our displacement vector, we're just going to take the square root of 5.35 squared plus 95.35 squared. So we find our magnitude to be 95.5. And we look back at our question and we started in units of kilometers. So we want to make sure that wherever we're talking about distance, we want to make sure we put a kilometer unit, right? So here our magnitude is in kilometers. And we could actually label our vector in kilometers. This is our answer to part B. Label that in kilometers as well. So now we look and we see, okay, we figured out how far the restaurant is from the post office. Now we're on part D. If they return directly from the restaurant to the post office, what is their displacement vector on the return trip? Well, we can look at our drawing before, and if they're going to take the same exact path of those four vectors, they're just taking them in reverse order. That just means negative 40 and negative 50 and negative 30 and negative 20. So rather than having to calculate that all again, we can just take the negative of our result on the trip there. It's just negative of the result we found before, since they're just going in the opposite direction. A little clearer. And so that negative can be distributed inside the vector as negative 5.35 and negative 95.35 kilometers in the x and y directions. And that answers part D. So for part E, it asks, what is their compass heading on the return trip? And it says assume positive x-axis is to the east, which we did. So what is their compass heading? Well, this is their return trip vector. And so if we were to draw said vector, we would have a slight negative in the x-axis component, just a little bit there, and a very large negative y component. So that resulting vector is going to be a pretty steep arrow pointing down. And so now we are asked to find an angle to represent where that is. How do we find either this angle or the smaller angle? We could find either one, right? And sort of describe where it is. So why don't we find this angle here? So what's gonna help us solve that is draw a triangle where this is your x component of 5.35. This is your y component of 95.35. And you notice I made them positive. That's because we have left that coordinate space, and now we are just drawing a triangle. When we drew triangles in geometry, we always used a positive distance. Now we're just trying to find this angle here. Well, remember from SOHCAHTOA, tangent works with opposite and adjacent, two values we have. So we can say that tangent of theta, which we don't know, so we're going to leave it as theta, is opposite 95.35 over adjacent of 5.35. And so by taking the tangent inverse of both sides, we find that theta equals tangent inverse of 95.35 over 5.35. And so this gives us a theta of 80.4 degrees. Now, we cannot just put this answer as 80 degrees. That's not right, because we don't know what that 80 degrees is relative to. You can see it's actually relative to that west direction. But what if, we were representing like the east or north or south direction? We don't really know. So we have to provide some context. And so the format of providing that context is, well, we look at our main axis. Are we going to the east or to the west? And are we going north or south? You can see we're going south, west. So 80.4 degrees. And the syntax of this is a little bit weird. We use either we're gonna say we are south of west. What that means is west is our baseline, and that points to the left, right? South of west means in this direction. If you were to say north of west, we would be starting with that west direction and going in the north direction, and we would have some new angle. But we are in the southwest, and we are by 80.4 degrees. So for our final answer, we have to write 80.4 degrees south of west. Just to provide that context that we are baseline west 80.4 degrees in the south direction. And that gives us our answer for question 7 on homework 2.